According to recent CRN research, 76% of organizations are already testing or using AI powered tools, putting greater pressure on IT teams to secure endpoints without slowing down innovation. That's why Intel and CrowdStrike have partnered to combine hardware level protections with advanced security software, helping businesses safeguard their data and realize the full potential of AI PCs. I'm joined by Todd Kramer from Intel and John Smith from CrowdStrike to tell me more about how this partnership is evolving to meet today's security challenges. My first question for both of you, can you tell me a little bit about yourself and your background?
Okay, I'll go first. My name really is John Smith. I've been in the industry about 30 years. I am currently working as an integration solutions architect. My role here, I've had a number of different roles over the last 30 years. But my role here specifically is to work with partners on the integrations. That includes, development, API access, that kind of stuff, as well as, helping with the go-to-market. So just a guy that spends a lot of time with APIs. Go ahead, Todd.
Great. And I've been at Intel about 18 years, and I've also spent my entire career in security. And my current role, there's lots of optimizations we have in hardware and silicon designed exactly for security solution vendors like CrowdStrike. So my job is to integrate with the ecosystem, make them aware of optimizations, and help drive those integrations.
Let's get right into it then. Why have Intel and CrowdStrike partnered together on PC hardware and endpoint security software?
Yeah, I think, we've had this partnership going on 4 or 5 years now. And we started this partnership, obviously, during my intro, we have certain optimizations in silicon that can benefit security solution providers to help accelerate, improve efficacy. And so we started with a number of those integrations that we talk about, but it really, when you look at two large players, Intel and CrowdStrike, we have large market share in corporate customers and SMBs and, in the market in general. So when you drive these type of optimizations, it really creates a premium bundle, if you will, of endpoint security. And so once those optimizations are in place, customers get better performance, better detection efficacy, and we're all out for the best. So that's, from my perspective, the reason for the partnership.
Yep. And I would add to that, right? And we're going to see it as we go through the presentation. But in the last 5 years, we've gone from 40% malware-free attacks to now 79%, almost 80% malware-free attacks. I know that a lot of marketing jargon says, insert technology here and say, this is the new perimeter. I don't think it's hyperbole to say that memory is becoming the new perimeter. Again, we have gone from 40% to 80% of malware-free based attacks. And what's happened is attackers have retreated into where they've found some opacity in memory. And what the Intel partnership does is it allows us to shine a light on that behavior. And it's one of the ways that CrowdStrike and Intel has evolved to meet the new threat.
Can you give me a little bit more background here? How does hardware security complement security software? What attacks does it focus on?
Sure. Let's turn to the slide here. Yeah, this gives a simplistic view of the typical kill chain, right? If you kind of look at this from left to right, threats move where they're trying to gain a footprint, initial access. They execute, they do things to evade defenses and persist. They try to move to the second PC or other infrastructure. They're laying in wait, maybe minutes, maybe months, right? And then they deliver their impact. And so along the way, you want to have different mitigations in your security software stack, but also your hardware stack, and know that, really I view CrowdStrike as your, security system of record that does a whole heck of a lot. It provides the bulk of your defenses. But the good thing is your PC itself also has defenses that help mitigate and build that defense defense in depth with software at each point here. We won't go through each one of these features, but like on a typical vPro device, we've got about 30 hardware features in there. They are designed to protect different attack surfaces and below the OS, and do a number of different protections, mainly out of the box because we've done optimizations ahead with security software. And then here today, we're going to talk about the two circled here, and you can see where they show up in the kill chain, right? Where the attackers are trying to do a particular move. we've got something in hardware that's optimized in software, CrowdStrike, that John and I will talk about. But yeah, that's a pretty early look at why hardware plus software makes sense. You want to build that defense in depth, have multiple mitigation options at each layer.
Yeah, and that works doubly so in addition to that, right? Leveraging the Intel hardware-based security, the GPUs and NPUs, this allows us to build AI-specific custom IOAs specific to in-memory, being able to police that in memory. So again, threat actors had enjoyed some opacity there. That has been taken away from them because we're able to leverage that in parallel processing of using the GPU to be able to manage memory scanning without an impact on the end user, or at least a minimal, I would say in most cases, zero impact on the end user. When you want to scan things like memory, doing that without impacting the end user and the performance of the system can be challenging. With the Intel innovation, with their vPro and the GPU capabilities, is it gives us that ability to interrogate memory on a regular basis and basically take away one of their preferred path, what is obviously the preferred path of attack.
Yeah. So simplistically, these optimizations between Intel and CrowdStrike, a lot of the work to integrate has been done, right? So it's a matter of combining the right hardware chassis, a vPro or core-based device, with the software, right? And then it's just a matter of, as we'll see, a simple toggle control to turn on. And so this applies also to generations of Intel PCs. We're coming up on our Panther Lake systems. Some people call that, we're moving past 15th generation. But these feature sets apply because you have an integrated GPU all the way back to 6th generation. So most fleets are capable for this capability if you're running Intel. And also, there's another feature we'll talk about that goes after ROP attacks, also to memory. So there's two features we'll talk about, very simple to turn on, and it helps you detect these threats earlier in the kill chain, as we saw before, and it's building that comprehensive security.
So as I said earlier, malware-free attacks have gone from 40% all the way up to almost 80%. Memory is rapidly becoming the new perimeter. With that, we need to be able to target that in-memory scanning. And what the Intel integration with CrowdStrike does is once we enable it, we are now interrogating the memory for any sort of attacks. One of the common things that we look for, basically, I was on site at a large financial firm and I said, look, anything that goes to raw.github-user-content.com, we need to interrogate because that has the potential to be fileless malware. There are plenty of things that are destructive on the Windows operating system, irrespective of whether you have a malicious binary on there. Attackers are using these incumbent tools maliciously, and they're able to find opacity when they operate in memory. Well, when you leverage the Intel vPro technology with CrowdStrike and our custom IOA specific to scanning memory, this removes an area where bad actors have enjoyed, and it takes away that opacity that they've been able to take advantage of for so long.
Can you tell us more about the capabilities and how this all gets turned on for customers?
Yeah, sure. It's pretty simple. We've done a lot of the work to integrate these features ahead, as I mentioned before, with CrowdStrike to make it simple. As you'll see later with John, it's a toggle control. But the features apply, we're at roughly 15th generation PCs now, but an integrated GPU is present all the way back to 6th generation. So most, if not all, enterprise fleets have this capability, and it's a matter of just knowing it's in the console to activate it. And also, we'll look at there's a secondary feature that looks at ROP attacks to memory as well. So two different feature sets from hardware that we've spent the time to integrate. And again, it builds this premium solution that only works on Intel, and it's sort of a no-brainer to use it, right? Toggle it on and let it accelerate the memory scanning to let CrowdStrike scan more and detect more. So why don't we talk here a little bit more, just to tee up the features themselves here. We call from the Intel side the optimization Intel Threat Detection Technology, or Intel TDT. And it's an SDK that we gave to CrowdStrike, and we worked to integrate that. And it is delivered in their tests up to a 7x boost in memory scanning capacity and capability, be able to scan more, detect more. And also I'll mention CrowdStrike is, when we first released this, it did sort of one mitigation for Cobalt Strike attacks that are common to memory. But CrowdStrike said, "Hey, we're going to be dropping more and more, detection engineering using this feature, and I think we'll see well up to 90 TTPs just from this particular feature. So it's quite powerful, and CrowdStrike has built a whole software module around it to keep continuing and innovating and using this feature in different ways. And then the second feature is called hardware enhanced exploit detection. It uses a dense telemetry on the Intel side called processor trace, and it's used to trace the control flow of the application to help root out, ROP and JOP attacks to memory. So these are the two features that you'll see as we get in there with John. And here's just another look at the architecture, kind of a architecture, if you will. You've got the chipset. It's got its integrated accelerated memory scanning. So it offloads, instead of scanning that on the CPU that would disrupt the user's experience, it automatically offloads to the high-speed parallel GPU. And that's integrated directly inside of the CrowdStrike Falcon Agent sensor. They've done the optimizations and work in their software to test it. And then they built the modules in the cloud that correspond to this to utilize this technology. So it's directly integrated in the Falcon Agent itself. And one last slide here before we look at a demo from John. Again, as I mentioned, these GPUs are quite powerful. And, they're not in a corporate environment. They're not being utilized for gaming graphics, things like that. A lot of this 128 execution units is ready for this type of use case. So it really does work very well in corporate environments to parallelize this memory scanning algorithm that's perfect for a GPU and leverages our system on a chip architecture.
John, CrowdStrike is known for its cutting-edge endpoint security. Can you give us a quick demo of how your solution works alongside Intel's hardware protections in real time?
Sure. All right. Do you guys see my screen?
Yes.
Yeah.
Okay. I have pretty much the easiest job, I guess, on the webinar. So to enable it, first off, buy Intel hardware. That's the first thing you'll want to do. Second thing you want to do, if you look here, it's literally just adding a couple of checkboxes here. Hardware, you want to enable hardware enhanced exploit detection. If you click on it, you'll get a little dossier on what the feature is and the minimum levels that you need from an OS and hardware standpoint to be able to leverage it. But then in addition to that, once you've enabled that, the next step, let me find my spot here. We have memory scanning with GPU. And you would enable this. Now, also, if a GPU is unavailable, you can do memory scanning with the CPU. Obviously, if you've invested in the Intel hardware, then you're going to be able to leverage the GPU and you'll be able to do those in-memory scans with minimal impact. That is basically it. 3 checkboxes. The last one's optional. I use all of them. I want to scan memory, as we saw in the 2025 threat report. That's the new perimeter. So I check both. And then I also check hardware enhanced exploit detection. Again, as I said earlier, this unleashes a custom set of IOAs that we've worked with Intel to build to interrogate the memory and again, take away that opacity that threat actors have enjoyed for so long.
John, thanks for sharing that demo with us. It's great to see it all in person happening live. Do you have the data to show what the impact of the capabilities are?
Sure. And, I'll sort of go deeper on what I talked about before. When CrowdStrike first released it, it looked for one mitigation, a Cobalt Strike attack, or a method, I should say. And then CrowdStrike has really expanded this out. They built a whole software module around this that leverages it for various different attack types. And so one way that we've proven this is CrowdStrike, Intel, and Microsoft actually joined together in the MITRE ATT&CK organization, and they create what they call you can map features to TTPs, and these are tactics that are used in that kill chain I showed before that are proven known countermeasures. And so here, when you look at this Cobalt Strike attack, it has different setup processes from phishing to malicious script execution and then code execution, code injection. And so each one of these things are different methods and stages of an attack that most likely is utilizing trying to get into memory, as John alluded to earlier. And here you see each TTP in hardware and hardware-enabled software in CrowdStrike that provides a countermeasure. And we mapped these two features with CrowdStrike, and CrowdStrike put a really nice blog post out about it, 93 mitigations. And so these are well covered across different parts of the kill chain inside the MITRE ATT&CK framework, and quite powerful feature. And if I go to the other proof points is in the real world, right? And actually Intel uses CrowdStrike ourselves as our EDR system of record. And here you see Brent Conrad and our IT organization and our SecOps team, which was rated #1 in the world as a SecOps operation company. And they did a case study on these set of features. So I highly recommend you go download it, but it talks about how they tested to deploy it, how they went through and performance tested it, looked at its efficacy. So if you're thinking about, many companies either take the default protections from CrowdStrike and turn them on, or if you're very careful about understanding what each and every feature does and how it works in your environment, it's great to look through and see what a large SecOps organization did to turn these features on. And we also have a YouTube version out there as well. You can hear Brent, giving the fast pitch of this particular feature. So, real world proof point is pretty meaningful. And then I'll mention here also, you can look at a video on that MITRE ATT&CK mapping from Sunil Sundar at MITRE. You can take a look at that. Also, the director of product management at CrowdStrike, he sort of has a quote here that talks about in their MITRE ATT&CK tests where they go head to head with other vendors, this AMS feature is quite instrumental. Again, looking because memory, as John said, is a common setup point for all attacks. And also here's Joel giving the VP of Data Scientists, he calls it their efficacy canon. They use it in conjunction with many other features to confirm early indicators of attack. And then I'll also highlight CrowdStrike as a telco case study where their managed detection and response Falcon Complete team for a large telco provider found a major attack for this telco. This feature fired and was helped mitigate it. So if you want to see this feature in action in the real world, lots of different ways to take a look at that.
John, anything you'd like to add? Yeah.
Yeah, I would. So just in summary, Todd did a great job of summarizing that, but just keep in mind, if there's any narrative that we've gotten here, if you are not using in-memory scanning, then you have a giant blind spot in your security practice. So, there is plenty, and we have next-gen SIM queries that you can run, and you can see these detections. You can actually see it's actually called a AMS byte pattern scan result. We actually have a telemetry event that we monitor that you can actually run a query and see the detections as they come in. So, again, if you're not scanning your memory, you're waiting for them to finish what they're doing and move to the next part of their kill chain, and you've got a big blind spot.
Let's pivot now and talk a little bit about AI PCs. First of all, what is an AI PC and how is this partnership evolving to address AI for security on client?
Well, let's just sort of start with, what technically is an AI PC? And so we're all familiar with the CPUs that power our devices or our compute engines. And as I mentioned before, the integrated GPU that's been there since 6th generation. We added a new neural processing unit on our silicon, and it's designed for sustained AI background workloads, and it gives longer battery life. And so, we at Intel have been, we're on the 3rd generation now of AI PCs that are capable to run AI and deep learning and machine learning directly down on the client itself. Not, most AI, as it always will be, are running the big gun computes and Xeons, et cetera, in the cloud by the CrowdStrike Security Cloud. There's lots of work they always will do there, but there's certain use cases where running AI as a model or a feature for data privacy reasons, faster latency, or maybe just access to the full set of endpoint data for detection, you're going to want to run an AI model right down on client. And again, you don't want to disrupt the user experience. So we've been working across the whole software ecosystem, not just security. And you kind of look at that little chart up there. Intel enabled about 700 AI-enabled features on our clients last year, including security providers. And you can see the mix of what they're targeting their AI to use between the GPU, NPU, and CPU. So that is technically the chassis, if you will, of what is an AI PC. And every PC is going to be an AI PC. And here's two different studies. One is Canalys, the other is IDC. And you're seeing here that roughly by 2027, 60% of all PC shipments will have this NPU across desktop and laptops. And this year, I think we're at 150 million, or about 41% of all PCs. Most of the PCs corporations are buying or refreshing have this part, right? So now we're going to start taking advantage of it with the software optimizations, and we have been working with CrowdStrike on this. And if you look away right there, that's where we're working together on to land this on client.
Anything that you want to add about the fileless attacks here? Todd, do you want to jump in as well to add anything?
Yeah, sure. We've covered all of these here. And again, you see this fileless attacks, again, 80% of all attacks are using this method. So you want to get great at it, right? And so those features John talked about, there are behavioral IOAs in software in CrowdStrike that they're using to go after these. But then your number 2 and 3 that we saw today, these specific hardware optimizations are helping as well. And then so in the age of the AIPC, we are in advanced collaboration prototyping the very first CrowdStrike AI that will run entirely on client to offload to the GPU and the NPU. And it, again, is going to go after an element of fileless malware, this byte injection attack, right? And so we're stay tuned for more, but we're actually driving and utilizing these new NPU capabilities directly with CrowdStrike. And you'll see at Falcon here, we'll be probably running some demos and driving some talks around it. So
I think we can all attest to, this emerging AI field is that it's kind of a double-edged sword when it comes to security. It both helps us improve our security posture, but it also gives attackers plenty of new opportunities to use these tools to fuel attacks. So tell me, how are organizations rethinking their security architecture to defend against emerging AI-driven attacks?
Yeah, I mean, it's the early days, right? There's a lot of wild, wild west going on where enterprises are putting out AI and using it in chatbots in different applications. Here I showed earlier, we're enabling the software ecosystem to run AI on client. AI is nothing but software, right? It is a known entity. It has models, it has weights, it has things, and it has targets and attack surfaces that are unique. So I'd say, AI on client or AI on the cloud, there's new threat models and attacks that are happening where that evil-based AI for malfeasance is happening. But you also have AI for good, and I just talked about it, right? The AI PCs, AI NPU, those type of things are features that will help AI for security combat some of that bad, that's happening out there. And the good thing to know is that a lot of the hardware that you have on a PC helps protect that AI, those models, from attacks that may happen from below the OS. We provide encryption for those models when they're at rest. And then you look into your software stack and your software providers like CrowdStrike that have other dedicated solutions, cloud-based and even that run on client, to help lock down other facets of AI-based security. So just think of AI as nothing new, but new attack vectors and new solutions to help lock down AI, no matter where it runs, on the client and in the cloud.
John, what's your perspective on that?
Yeah, very similar, right? With any innovation that's happened, in human history, the vehicle, well, people can use cars for 99% of the time for good, but they can use them for bad things. AI is the co-pilots and the agentic AI capabilities are going to be game-changing and life-altering for society. Likewise, people will do bad things with AI as well. And so, as I stated earlier, right, first off, Intel's being very responsible by embedding their own security capabilities. But again, as we watch AI evolve, it's important that we demand from our vendors that they be working with this and they be building innovations to protect it as well. So a lot of great things are going to happen. I'd like to think we at CrowdStrike are a little bit ahead of the curve on this. And my hope is that we can enjoy all of the great things that AI is going to bring to the world, but at the same time, we can do so in a manner that keeps it safe and protects end users' information and property.
That about wraps up for us. Can you tell me, where can our viewers learn more about everything that you've talked about today?
Yeah, we've done lots over the years with CrowdStrike, right? I pointed to that Anchor solution brief, and this is actually a three-way one with Dell PCs. So if you want to get a grip about how these features work together, you can scan that QR code. Highly recommend that solution brief. You can watch a video from Joel Spurlock, the VP of Data Science, about how they're evolving AI on client with Intel. And you can also read the blogs, right? We put out a couple blogs about, the testing and the proving grounds of how we discover which use cases we're going to apply AI on client to. And as I said, we'll be at the CrowdStrike Falcon shows in September and then in Barcelona in November. And we'll be running demos and driving additional talks about this AI PC, AI on client approach with CrowdStrike.
Todd and John, it's been a real pleasure talking to you both about the Intel and CrowdStrike relationship. I'm excited to see where this goes. And thank you so much at home for joining me. For the Channel & Company, I'm Caleb Owen.